Hi guys, welcome back. This is a second video in the Amstrad series. So in the previous video, I looked at the hardware and we had a look at how the Z80 chip works with some of the other circuitry and this device goes together. We also looked at the basic programming language, just a few simple examples, including what we've got on the screen here. But in this video, we're going to look at data recovery and specifically using RS-232. Now, I sort of briefly explained this in the last video, but for the newcomers, I'll explain this again. My grandfather wrote this pretty hefty book, and it's a family history. It includes a lot of research that he's done. Spent a lot of time, 12 years in fact, correspondence and research and authoring that book. Now he's saved that entire book onto these proprietary 3-inch floppy disks. These are dual-sided floppy disks. They're not the 3.5-inch floppy disks that you might be more familiar with. These are a proprietary physical size and a proprietary file system. It's different from the normal IBM compatible disks. Now there's a few ways that I can transfer data off of these. There's a secondary disk drive on here, and you can actually adapt a 3.5-inch floppy disk to work with this device. And then you can write data to those disks in a weird format. Then you can run it on a more modern computer using a CPC emulator and read the data out, and there's an extraction process like that. The other way to do it is to use the same process but with one of those disk drive emulator pieces of hardware that take a USB stick or an SD card. You can do the same thing. But I decided to do it using RS-232 because I was able to source this in Australia locally, and I hadn't seen any guides online on how to do this process. They sort of said, yeah, it should be possible, but we're going to figure out how to do it, and I think it'll be interesting to document that. The other thing I've got here is my little USB to RS-232 adapter for my Surface Book. The Surface Book only has USB ports, and so that's what we're going to use to connect using this expansion module into the Amstrad. So I think what we'll do is we'll have a look at what's inside the box here. We'll have a look at the actual expansion hardware itself and take it apart, see what's going on in there and how it works. And then we'll see if we can get this connection to happen, and hopefully we can get some data going across the computers. So here's a closer look at the box that this came in. As far as I can find, just researching these things, there's two versions that you can get. So there's the Amstrad version, which was earlier than this one, and it had a few issues as far as I can tell. So the better one is to try and get the one by Pace. This came out afterwards, and it's superior as far as I'm aware. Apparently the software that comes with it is pretty good too. So this box, you can see it's a bit water damaged and a little bit moldy, and it's held together with some packaging tape, and it's a bit grotty, but the insides aren't affected by that, so it is what it is. So it explains here you got Viewdata mode and terminal mode. So when you plug this thing in and you fire up the software, you got two modes to choose from. So we can have a look at that in a little bit more detail later. But let's open the box carefully. You can see it's got the styrofoam packaging here, and there's a manual. It's a nice thick manual like they used to be back in the day. Because there was no researching this on the internet, it had to come with all the instructions. So this manual, it includes a little cheat sheet that the previous owner had, and that was quite handy when I first got up and running. But we'll go through these commands in a bit later as well. It came with this MicroLink with Telecom Gold, British Telecom that is. So there you go, some nice old school modem and receiver there. Oh, look at that. That's high tech. You got your briefcase with a handset modem there. So you plug your handset on, it's got a speaker and microphone, and it communicates over that. That is, oh look, passport. It's like James Bond. And registration card. So I dare say that they're not around anymore. But yeah, British Telecom had this MicroLink service, and it was basically like the precursor to like the internet as we know it today. So you could subscribe to this, you pay a fee. I think in the back here it's got, here we go, how much does it cost? So £5 to register, and then £3 per calendar month. And then connection charges 3.5p per minute or part cheap rate, 11p per minute or part standard rate. There's a few other bits and pieces there, telemessages, radio paging, MicroLink PSS service, whatever that was. Yeah, so this pamphlet sort of goes through the service and all of that. And they had like an email service and things like that, and the old school bulletin board systems were sort of running. You'd connect to them using your Telecom MicroLink connection. So that was actually in the front page of this manual, and this manual's a little bit, get a little bit of water damage on there as well, and the pages are getting a little bit, you know, starting to fall out, so I just got to be careful with this. But you can see how good this manual is. I mean, it's got everything in there. It's really comprehensive. It goes through all the commands and how to use this thing, the you know, the color codes and everything, RAM buffer, everything you could dream of. If you want to know how this thing works, you can sit down. There's your 232 interface connections. So we'll definitely be using this later because we're going to have to figure out how to wire this thing up. So page 83, good year that. Error codes, hopefully we're not seeing too many of them, and the index. So really good manual. I was glad that it came with that because yeah, that's definitely, I'd be lost without it. I think you'll probably find this scanned in. There's that CPC Wiki website. Google that place, it's awesome. They got all sorts of PDFs and hardware guides and things. So here's the hardware itself. I'll just shift this out of the way. And there it is. So you can see they've got the two different type of connections here. The computer I have has the card edge connector, so we'll be using this connector here. And this one would be for, I think there's like a Schneider or European version of the CPC, and I think they used a different type of connector, so that's probably what that is for. On the back, 4 screws, and there's our 25-pin serial connection, RS232 connection. So let's take to this with a screwdriver and see what's inside. There we go, surface mount, did not expect to see that. So that looks like the back side of the PCB. Let's flip it over. That's more like it. That's what I was expecting. So a little bit of everything in this board. Let me zoom you in and we'll have a bit of a closer look. Straight away you can probably see this Zilog chip, and I think I pronounced that Ziglog in my past video. That's an old habit I've had since I was a kid. I used to keep calling it Ziglog and I can't kick it. So Zilog chip here, it's in the Z80 range as you can see. It's the Z8442 APS, and this is a serial I/O controller, and it's got 2 full duplex channels in it. And I believe what's happening is this is doing all of your serial framing, so your packet framing. So if you set, say, 8 data bits, no parity, 1 stop bit, your baud rate, all of that sort of stuff, I think this chip here is buffering that, framing it, and doing all that sort of things. Whereas this chip here, which is IC5, that's a Texas Instruments SN75189N, and that's a quad line receiver. And this has got plus or minus 30 volt inputs, so it's totally in spec for RS232, and it's actually designed for use with RS232. So this is more of like the physical signaling side of it, and this is the more of the protocol side of it. Now this Toshiba chip down here is quite interesting. It's a TMP8253P-5, bit of a mouthful, but that's a programmable interval timer, which is interesting because nowadays we take this for granted. Like any microcontroller, any sort of little chip has inbuilt timers and interrupts and all sorts. But back in this day, they had to have a separate IC just to do the timing. So this has got 3 16-bit counters in it, and it can count in binary or BCD apparently. And down here you've got the ComStar, that's obviously the ROM, so that's where the software is on there, and you can see someone's written with a pen CPC. So I'm assuming they had different versions of this board, maybe for, you know, Commodore 64 or Amiga or whatever it was back then. But this one's been burnt with the CPC software specifically. And then there's another slot for another PROM or EPROM of some sort. And you see it's a 27128 or 256K EPROM that could go in that slot. So that's about it for that side of the board. I'm going to flip it back over to the underside where we saw those surface mount chips. I'll run through these quickly. So these are all sort of like logic chips. They're all 74 series style stuff. So you've got this chip here is a quad OR gate. That's IC6. IC7 is a quad flip-flop. And IC8 here is a quad NAND gate. And then these three chips, this one, this one, this one, are just different MUX decoder chips, multiplexing chips and things like that. So that's basically it. And we've got our 25 pin, so it's a D sub 25 connector here. So nowadays, when you say serial port, you're most likely used to seeing the serial port like on my little USB to serial port adapter here, which is a D sub 9 connector. So we need to make a cable that connects between the two. I think that's called a null modem cable. You can buy them off the shelf, but just to be sure, we'll wire up our own just to make sure that we've got everything we need here. So I went down to the electronics shop and I've got these two connectors. So you see they're just like the solder type. They've got the solder cups on the back. So we'll be able to wire that up, and we'll use that page out of the manual to explain that. And also, this is what I'm going to wire it with. So I use this really fine wire wrapping wire. I find it's great for PCB repairs, bodge wiring, and because it's solid core, it's really fast and easy to wire in these solder cups. So this is a little bit awkward to film, but I just wanted to show you where I'm plugging this 232 expansion in. So there's an expansion port here. It's the widest slot there, that connector. So basically I'm just going to plug this ribbon cable into that. If I just line it up, there it is. It just plugs in like that. And then we've got our D sub 25 232 port there. And the Amstrad is going to read from the ROM in here to provide the software for it. Quick look at the configuration before we power up here. We've got our Amstrad CPC 6128. We've got our GT65 monitor, monochrome, beautiful green. Amstrad RS232 by Pace, our expansion module with a D sub 25 RS232 port, waiting for us to load off the ROM and send some data. Now, before I go plug it in my Surface Book or any other computers, I want to check that this is doing the proper things. So we're going to test the voltages with my Fluke multimeter here. And if the voltages look good, then we can plug in our logic analyzer and we can have a look at the 232 waveform and just confirm that this is putting out what we want it to put out. And if that all looks good, then we'll plug in our laptop and hopefully we'll get some data. Alrighty, let's power up the Amstrad. And we've booted. Windows have got nothing on the boot times of this thing. Remember before I said that this cheat sheet came in handy? I wasn't joking, because this cheat sheet, oh, that CRT, that static is holding my note for me. Let's just leave that there. Nice. So you see it's got a pipe CS. This is basically the command to load the ROM off of the expansion unit. So if I go pipe CS, return, it brings up this menu. Let's get rid of that for now. It brings up this menu. And there's two options. You either do one, Viewdata mode, or two, ASCII mode. Now, previous owner has written two, so I went with that. Now, I'll quickly go into number one. I don't know what this is particularly. It's got Honeyview down here. It's got some sort of timer online, apparently. So I'm not sure exactly what this does, but if I hit Control 0, you can see it's got mode. I can clear and inks. It's got these things going on. I'll escape out of that. Control 1, I've got my transmit baud rate, receive baud rate, parity, data bit, stop bit. Control F2, file, save, load, cat, erase. So this is something that, searching for header, telesoftware, searching for header, not a header frame, download aborted, press any key to continue. Control 4, 5, 6, 7, place, printer online, escape to abort. Yeah, let's get rid of that. F8, disk, tape disk, disk A or B or HT, hyperterminal, don't know what that is. Control F9, user keys, load or save, so you can have custom things there. No idea what any of this means. I should probably RTFM, but I'm not going to do that at the moment because I think the more promising thing, I'm going to actually have to reboot the computer now. Doesn't take long. There we go. And I'll show you option 2. So pipe CS, whoops, hang on, that's not the pipe. Pipe CS. Let's do ASCII mode. Here we go. So this looks a little bit more promising because I've actually got a blinking prompt here and I can type stuff. Now, nothing's appearing on the screen, but if I'm not mistaken, I think that's actually transmitting data out of the 232 port right now as I type. So we can test for that. First of all, let's just go Control F0. See, this is looking, this is where I've got to so far, and when I was sort of like clicking around, and this is looking more promising because you've got X on, X off, auto line feed, echo. Actually, if I turn echo on, let's just escape. Now if I type, there we go. So echo means that it basically feeds back to itself what you're transmitting. So we can do echo on and off. I'm just hitting the enter key to toggle that. Let's leave it off for now. Line wrapper 80 characters. Cursor under blank. Oh, that might just be like the position of the cursor, how it's visually shown on the screen. Reverse video. Wow, okay. Yeah, sorry about that. Hope it's not too late at night when you're watching this. Delete 8. Okay, so I'm actually used to delete being 127. This is just like almost like a protocol thing. It's like, what is a delete key, like the backspace key, transmitted as? And most protocols and things that I've played with, it's been 127. I'm going to leave it like that. Character 35 on the ASCII table, is it pound or hash? I'm more used to that being hash. So I'm going to leave it like that. Let's escape out of that. So Control F1. Okay, here we go. RS-232, this is looking good. Transmit baud rate, it's 300 baud. Receive baud is the same as the transmit baud. So let's hit enter. Oh, look at this. So I can select any baud rate that I want. I'm just going to leave it at 300 for now, just because default setting. And a slower baud rate isn't going to hurt for what we're doing at the moment. Yeah, no parity. 8 data bits, 1 stop bit. I know that 8N1, which is 8 data bits, no parity, 1 stop bit is the standard. But it really should be 8N2 as far as I'm concerned, because you're not putting a parity bit in, so you should have 2 stop bits. When I write 232 software, I usually write it like that, but I know this is like a quasi standard, so I'll leave it like that. Soft handshake or hard handshake, I guess that's using like the extra 232 signal lines to signal whether it's ready to keep talking and all of that sort of carry on. We'll leave it on soft. Par check on and off, don't know. Let's just leave that one. Escape. Control F3. Did I do Control F2? Oh, here we go. Control F2. File. Save, load, catalog, or arrays. Okay, interesting. We'll come back to that. Control F3. Transfer. ASCII or X modem. I know what ASCII is, so we'll stick with that for now. ASCII receive. What? Oh, this is like file transfer. Enter a file name. I'm going to escape out of this. We're going to check that out later though, because this is, I think that's what we want to do eventually. We want to be transferring files, and we can choose how it transfers, and we can point it to a file on a disk perhaps. Let's exit out of that. So we're back here. I turned echo off, didn't I? So at the moment, let's just turn echo back on, just so you can see what I'm doing. Echo on, escape out. So I should be able to, there we go, delete that. And does it support uppercase, and lowercase? Very cool. Okay. So I think what I'm going to do now is I'm going to get my multimeter and I'm going to plug it in to the 232, the 232 port here. The pin out here is what I'm interested in. So I'm trying to find the transmit pin and the ground pin. So between the transmit and ground, if I put my multimeter leads on that and start typing, I should see the voltage fluctuate if it's doing what it should. So give me a moment. I'm going to go to the manual. It was page 83 from memory. And there it is. So this is the pin out. You see these pages are falling out. So we're looking at transmit data pin 2, and where's our signal ground? Pin 7. So between 2 and 7. Alright, let me grab my multimeter. Alright, let's see if I can get this multimeter in view. Backlight on, there we go, you can see that. Now I've got to find pins 2 and 7. I'm going to put these probes directly onto those pins. I'm seeing something. I'm seeing something there. So we've got voltage coming out. So that's putting something out on that transmit pin. That is awesome. Okay. So we know that it's trying to do something. Whether or not it makes any sense is the next question, but I reckon that we've got a working unit here, which is awesome news. So I think the next thing I'm going to do, because we've got that pin working, I might just plug my logic analyzer directly into the transmit pin, and we'll start typing some garbage and see if we get a decent signal coming out of it. So let me set that up and we'll cut back to that in a sec. Okay, so apologies first of all for actually recording my screen and not doing a screen capture. It's because I wanted to show you my little logic analyzer down here. That's plugged into my Surface Book, and I've just wired that in there. You can see there's the grey cable going into pin 7, which is ground, and the black cable going into pin 2, which is our transmit pin. I've got a camera pointing on the Amstrad and a camera pointing on my Surface Book here. So let's add our data 0 black wire signal. Now if I type in 1, 2, 3, 4, not working. Sorry, I've got to trigger it. Okay, let's trigger this. 1, 2, 3, there it goes. Did you guys see that change? Hang on, let me zoom you in. So there, if I type in D, A, 7. So this is awesome because we're receiving, that's like a really clean signal there. And in fact, I should be able to add an interpreter. I'm going to go 232. Okay. 7. It's doing it. 7. S. That's awesome. Exclamation point. M. Capital M. All right, this is awesome. Oh, check that out. So if I type in a bunch of data in a row, you can see it's trying to send that through. That's awesome. Okay, so this is really good news. So this is just the transmit pin, but we're decoding the signal here in my Surface Book. Now this is not practical at all. I can't use a logic analyzer to decode files and stuff like that. So what we're going to do is we're going to wire up from our D sub 25 to a D sub 9, and we're going to wire just the ground and the transmit signal into the receive pin on the D sub 9. Then we should be able to use our little USB to 232 converter and open like a terminal window like PuTTY or something like that on this computer, and we should be able to then receive data as we type it. So let's jump downstairs, grab the soldering iron and get that sorted, and then see how we go here. So let's solder this little cable for testing. So we need to do a transmit signal and a ground signal. Now we know that's pin 2 for transmit, pin 7 for ground on this connector here, as stated on page 83. You can see 2 is transmit, 7 is signal ground. Now I've done enough of these D sub 9 connectors to know that pin 2 is receive and pin 5 is ground. So that's what we've got to wire up here. And I've got my wire wrapping wire here. This is good stuff to quickly make connections. So let's do it. So we've soldered the transmit signal to the receive signal on the 9 pin here. So we're ready to go upstairs, plug these in and start seeing if we can get some data talking. So now I've plugged that cable into the Amstrad and into my little USB to 232 adapter here. And it looks like we're registered as COM3. Look at this, it's a CH340. This adapter was cheap as chips. It's like the cheapest one I could find on eBay. But it's obviously based on the CH40 chip there. COM3, so let's open PuTTY. Okay, let's configure PuTTY to use serial, and we know it needs to be 300 baud on COM3. Alright, and open. So here we go, moment of truth. So let's type in hello YouTube, it's working. Okay, this is awesome. That's awesome. All right, enter key. Okay, so it doesn't line break properly, but we can figure this out. Enter doesn't line break, but interesting. Can I delete? I can't delete. Gee, that's weird. Okay. So we don't have multiple lines at the moment. There might be some control character I've got to send to do a proper multiple line thing, but or maybe there's something in PuTTY. Change settings. Implicit carriage return in every, implicit line feed in every carriage return. Let's see if that works. Hello, enter. World. Awesome. Okay. This is really cool. All right. So that's 300 baud and it's fast enough for my crazy typing there. What do I do now? I wasn't expecting it to work like this. This is really good. I think I'm going to take that one as a win because that went a lot better than it could have. It didn't take me that much time to get the settings and the hardware set up and transmitting data. So we've proven that the RS232 is working for transmitting data. In the next video, I'll be interested in getting data received back onto the Amstrad. So we'll transmit it from our Surface Book over here and see if we can read the data in on this. Once we've got that working, then we can start trying to push files across. And that's where it's going to get really exciting because I can then back up all this data on these old disks. I can read the files off and send it across. But the other cool thing is I could download abandonware and programs off the internet and I could transmit them back and save them to disk and run them on the Amstrad. So if that sounds like something that you're interested in, please check out the next video and I'll see you soon. Thanks.